have the variance of the Gaussian, and in one case it is P0 tau.
Oh yes, sorry, I missed a...
There should be some P0, at least in...
Yeah, here. Sorry, I missed this thing here. Thank you. Yep. Right. Yeah, it's up there. Okay. This is proportional to our prior on tau. And then this term here. So this is just a inverse gamma. So this is the product from J equal 1 to D. So it's proportional to product from J equal 1 to D, tau J to the A1 minus 1 exp of negative, sorry, this is a inverse gamma, negative A1 minus 1. And then we have negative 1 over tau J times A2. Now we have this thing here, which is proportional to tau J to the 1/2. So we still have this product here. Tau J to the negative 1/2. And then we have exp of negative Wj squared over 2Cj times 1 over tau J. So you can see that our updated parameters of our gamma here are tau J minus A1 plus 1/2 minus 1 exp of negative 1 over tau J A2 plus this thing. Okay, so tau J are just independent gamma, inverse gamma, with updated parameters, A1 hat, A2 hat. So A1 hat is this thing. And this is A2 hat. Okay, almost done. We need 2 more steps. Okay, step 4. So step 4, we'll sample the P. P, given all of our other parameters, the latent y's and the data. So this is just proportional to our prior on P. And the only other term which depends on P is this up here, right? look at our model, this is the only one that depends on P. So we have P of C given P. Okay, and this is beta there. So this is just proportional to P to the B1 minus 1, 1 minus P to the B2 minus 1. And we have that this term here, well, if you write it out, it's just proportional to P to the what I call N1 and 1 minus P to the N naught. So N1 is equal to the number of CJs equal to 1. So that's just the sum of CJ equal to 1. And N naught, this is the sum of CJ equal to V naught. Okay, so we just have that this is a beta with updated parameters. This is B1 hat. This is B2 hat. Okay, and we're almost done. Our last step is to sample the latent Y's. Step 5, sample the latent Y tildes given all the other variables and our data. So this is just proportional to So this is exactly what we saw for the per-bit regression. This is just the normal, the truncated normal. So it's less than 0 if Y is equal to 0, and it's bigger than 0 if Y is equal to 1. So we just sample these YI's independently from a truncated normal with the appropriate truncation defined by our output Y. Okay, so that is the spike and slab prior, how to sample it using Gibbs sampling. Okay, so any questions? Yeah?
Go through the sampling algorithm, like with a choice example with like the data point?
So what do you mean in that? So in that case, our updated parameters, so if we just have 2 data points, or even let's just consider 1 data point, If we just have one data point, at this stage we have one latent variable y tilde. So it doesn't really matter the order in which we do these steps, right? So we'll start with 5 since I still have 5 on the board. So if we just had one data point, we'd sample one latent variable y, and this would be suppose that yi is equal to 0 and xi, let's make this have 2 dimensions. So this will be, I don't know, 1, 1, 2. So in this case, d is equal to 2. So at this stage, we'd go through, we'd sample our latent y, and this would be a normal with mean of x transpose w, whatever our value of w is at this step. And this latent y would have to be less than 0. So we'd sample from a truncated normal less than 0. So if w is equal to, at this stage, if w is equal to 0, 1, then our mean would be 2. We have a variance of 1, and we want to sample from this tail here. Okay, and that's step 5. Step 4, well, this doesn't actually depend on this update step doesn't depend on our data, it just depends on the values of C, J. So this, if we continue with this, considering that W is equal to 0, we can consider that, well, this one's 0, so maybe C1 was equal to 0, and C2 was equal to 1. So we can calculate the updated beta in this case. 1, 1. We go through. We have sample from a beta. And then, let's see, the other steps that we erased were sampling the weights, the C's, and the taus. Okay, so the weights conditional to this data.
One thing is beta, the parameters will be v1 plus 0, and v2 tilde will be v2 plus 1, because the way we calculate is to sample p and to sample p, to sample probability with the v1 beta and v2 it will be v1 and the v2 plus 1 because of the state of the C.
This state here. Well, we have one value equal to 0 and one value equal to 1.
So what would be the parameters of the beta?
Wait. Sorry, I meant this is V naught. This should be V naught, not 0.
No, it should be.
So it takes values V naught or 1.
Okay.
So I have one C that's equal to V naught and one C that's equal to 1. So these N1 and N0 would both be 1 in this case. So yeah, that would be our updated parameters of the beta. Would you like me to go through the other steps? I can. No. Does that help at all? Yeah. So Usually in the full Bayesian model, when you read through these papers, there's several steps like this, 5, 10 updating steps in the Gibbs sampler. So it's easy to get lost reading these things. Okay. So should we? Oh. Okay. So yeah, we'll just start with Dirichlet tomorrow.
So, do you have any more questions? This example or the previous example. We will leave the Dirichlet process for the next lecture because it seems to me that doesn't make much sense to start today. And talk about it for 5 to 10 minutes. So, do you have any more questions? No? Okay then. Thank you, Sarah.
Okay.
For the example. And we'll see you again tomorrow morning and we'll start with the Dirichlet process.
So what is the difference in these two papers, the John Standard and
So the first one was the original, yeah.
and this one's the price-stick model? I think it is probably similar, or they change something?
Yeah. They're all. So this was the last formulation of the model. So they slightly changed a couple things in the later papers, and then in the last one especially, they also changed some properties.
Oh, so they do some analysis. They do more.
Some theoretical properties as well. But they formulated the model.
For my thesis, I actually implemented this system, but more based on the first paper. And yeah, I think what I did is when you sample these data you can marginalize the data.
Yeah.
Because yes, and I think that it eliminates these other operations in the database. They are much smaller. It is more expensive because you have to something this CJs would be more expensive because you marginalize all the database. But if you look at the operations that you get in the they are much smaller. I think I did this with my brother, and at some point some guys were not marginalized the database, and they asked him, what's the difference if you don't marginalize the database and you marginalize them? And he compared he implemented the two things, I think, and compared the autocompletions, and in this case they are much larger. But this is much simpler to implement. The give sampling method, this is super simple. In the other case, if you marginalize all the W's, the problem is that you have to do Chomsky's updates of the...
But in this case, if I did it,